Okay. Today you may see me like look downwards because I'm also connecting to my iPad, because later we're gonna have some examples we're gonna work together, and it's easier to working from my iPad. I can just write on the slides. So here we go. Okay. Also, I heard from the news like today, like this morning, supposed to be like one of the coldest day this year. Like it's like luckily we have this online, so we don't have to go to campus under this weather. Anyway, so today's class we're gonna trying to cover chapter 1.6, which include all the circuit elements. For me, I think as I stated yesterday, did someone just, oh, my internet is not stable, okay. I feel like did someone just said something? Okay, no, okay, good, let's start. As I stated yesterday, like circuit is an interconnections of like circuit elements. So this relationship is like, for me, it's like rows Lego pieces, and a finished Lego project is like circuit elements to the circuit. You can have a lot of different designs and combinations you want, but to make sure you really are building something instead of just putting all the pieces together, you have to really understand what pieces you have in mind. And circuit analyze is actually the process of understanding and figuring out what voltage, what current or power going through each element.
Professor?
Uh-huh.
It seems like you're breaking up for all of the class. I'm having a hard time understanding you.
Oh, I'm sorry. I wonder whether that's because I connect to my iPad or not. Because maybe. Okay. Okay, let me try to disconnect with this, and then maybe we'll start. Let me restart. Okay. Thank you. Let me know that. The end of the show. Okay. Just disconnect. Oh. Maybe for next class, I'll try to figure out a better way, or maybe it's my internet connection. Okay. Let me try to. Okay, let's reshare. And let's restart it. Okay, I think it's an iPad. The iPad connection is not stable somehow. I may just buy a like connector later today, so maybe that way have a better like connection for future class. So today we're just gonna do this. I'm gonna reshare the slides, and yeah, let me know if you still seeing like the breaking out or breaking up, like, or lagging situation. If that's still happening, just let me know. Okay, where we left. Yeah, I think as I said, like you really need to understand what pieces you have in your mind to build the final circuit. So the whole process of circuit analysis is to before that is to understand and to look at the circuit and to see what voltage and what current and power going through each element in the circuit. So what pieces we normally have in an electric circuit, which are the circuit elements? So we have active elements and the passive elements. So the active elements are those are capable of generating or providing energy to the circuit, such as like voltage source, current source, or generators. Then the passive elements are those can only receive energy, like resistor, capacitor, and inductors. They cannot provide energy in the circuit in any way. But there's one thing I want to point out is like even the active elements, they are capable of supplying the energy to the circuit, but it doesn't necessarily mean they are doing that function in certain circuit. So you have to analyze it. You have to figuring out whether they are working as a supplying or not. And we'll later see some examples. Okay, let's look a little bit deeper, more into the power source. So there are voltage source and current source. Both deliver power to the circuit and connected to them. Then there is a so-called ideal independent source, which provides a specific voltage or current, no matter what the rest of the circuit element change. In the circuit diagram I showed in the figures down here, this is normally what we will expect. From here, I showed a independent voltage source. And also sometimes you can see from here, like it will have the polarities, and also you can see like the specific voltage it supplies here. Or you will see the polarity symbols inside of the circle sign. Or if it's an independent current source, and you will see the current, the specific current it provided next to a symbol, and also an arrow inside of the sign. So those are really like obvious signs we tell by whether it's an independent source or not, or whether it's a independent voltage source or independent current source. Oh. Okay, so of course, since we have independent source, so we will have dependent source, which we also call controlled source. It provides a voltage or current whose magnitude is decided to another voltage or current in the circuit. So which by it could be another current going to another element, or another voltage across another element. So to represent this in the circuit, we normally will see a diamond shape, similar to the independent ones we'll see for the polarity sign for the voltage source, and see the arrow for the current source. So let's look at this figure together as an example. So this 5 voltage is an independent source, because we can see there, here we see the polarity sign, and we see this specific assigned number for this power. So this is a independent voltage source. However, this source here we see is a dependent voltage source. First, it has this positive and negative sign. So it's it's a voltage. So it's a voltage source. I know it can be really confusing, because you will see like the value next to it is like 10I. Like you say, oh, it's I, so it probably should be current. But no, we should never determine a source, whether it's a current source or it's a voltage source, based on what it dependent on. We should always focus on the symbol. If there is a polarity sign on it, then it's a voltage source. If it's an arrow, then it's a current source, no matter what the value it dependent on. Also, because this is a diamond shape, so with a voltage value of 10I on it next to it, so it is dependent on the current I going across the element C here. So for example, if the current I observe going through, where's my, okay. Going through the element C here is 2 amp. Then, which tells us this voltage source will provide us 20 volts. Okay, here is another example. I really wish I can just use, let me see whether I can use a pen somehow. Use maybe my touchpad as I use it. Oh, okay, no, okay. I'll just try to, okay, I try to use my mouse. Okay, let's see this example. Let's calculate our every all the power of each element in this circuit together. So let's start with here, P1. So first, let's look at what P1 is. We see a circle sign, so which means it's an independent source. And we see here with the polarity symbols in it, so it's an independent voltage source. Okay, then let's calculate the power of it. So we see there's a current being telling us there's a current going out from the positive sign. So the current going this way, going out from the positive sign, which let us know this element here is supplying the power out. So the power is supplying power, which we can know the power will be negative. Or you can think in another way, the current is going out from this positive terminal of this element. So we'll see the current is against the voltage direction. So the P1, oh God, it's hard. The P1 is equal to -5, oh my God, this is ugly. Okay, negative 5 amp times 20 volts. It's not working. Okay, I'll just talk. We'll try better next class. -5 amp times 20 volts. So it's like -100 watts. Any question on that? Like, do you guys understand why it's being negative? Okay, so we'll move on to P2. So P2, we see this looks like it's not a source anyway, so it can be a resistor or any element which will why is negative? Okay, I'll re-expand. So there's two ways you can think about why this power is negative. First, like I said, we identify this element as an independent voltage source, and the current going out from its positive sign. So let us know this is the element to providing the power. So this is the element to providing the power to the rest of the circuit. So for this element itself, it giving out the energy, it giving out the power. So for the element we are thinking for the P1 itself, it's like supplying, it's working as a supplier. So it's supplying the power. So which makes the power negative for the P1, for this element. That's one way to think about it. And another way to think about it, like actually I prefer more second way. The first way is more is what like be teaching on the textbook. The second way to think about it is, second way to think about the power being negative is we assign a direction of this on the circuit. We assign this more conventional way to assign the negative positive direction. The way I assign here is like we assign if the current going out from a positive, no matter what element this is, if the current going out from the positive terminal, then we see the current is negative. If the current is going in for that element, it's going in from the positive terminal, then that current is positive. So we can assign this direction for the whole circuit, for the whole system, for calculation. And we will later, after we calculate out all of the elements power, we can see it actually really have a closed loop. Yeah, like we will calculate out all of the elements, and then to see whether that makes sense to you later or not. Then if still you still kind of confusing, I will try, maybe we can find another way to explain this. Okay. Ooh, somebody says something on the chat. Okay, yes, supplying is, you can understand supplying is negative, receiving is positive. That's one way to understand this. Okay, so again, P1 is equal to -5 amps times 20 volts. So it's like -100 watts. Oh my God, it's really hard. So P2 is, if we taking the second method we used, so you see the current is going in, the current is going into the positive terminal of this element. So the current is positive. And also going this direction, the voltage is also positive too. So P2 is equal to positive 5 amps times positive 12 volts, which gives us 60 watts. In P3, similarly, this current going into P3, going into P3's positive terminal, and so make this current positive for this element. And also the voltage across going this direction is positive too. So P3 is equal to positive 6 amps times positive 8 watts. So which gives it positive 48 watts. Okay, P4. So here P4, obviously it's a source. So what kind of source it is? We see a diamond shape. So it's dependent source. And also we see an arrow inside of this shape. So it's a dependent current source. Okay, so which means this value we see here is a current value. And what is I? I is 5 amps here. So the I going across, the I provided by this source is 1 amp. 1 amp. And also, according to the arrow's direction, we know this current going through this way. So we have a current going up here with 1 amp volume. And what's the voltage across this? Here we see this dot, they are equivalent. And this dot and this dot, they are equivalent. So, or you can see this, the voltage across this element is equal to voltage across this element because they are connected to the same equivalent knot. You can see they are parallel to each other. So, which makes here positive, here negative, and the voltage across this element is 8 volts. Similar as this one. So what is P4? We see the current going out. The current is going out from this positive terminal. So the current is negative. And if we are looking through this direction, the current is negative, but the voltage is positive. So P4 is equal to -1 amp times 8 volts, which is -8 watts. Okay. Now we calculate out all of the power. So I'll ask you to do one thing. What if you put all the power together? put P1 plus P2 plus P3 plus P4. What result you got? Yes, you got 0, which makes total sense because I said earlier, oh, I didn't say this earlier. Okay, correct it. I didn't say this earlier. So we get we plus P1, P2, P3, P4 together get 0 watts because in any closed circuit, in any closed system, you will always get the supplied power, how much power you supplying to the circuit. That's how much power you receiving, you consuming in the circuit. So you will always, in a closed system, you will always get 0 watts. And that is making this like the first method kind of wholesome because that makes sense. Or if you see, what about I use the second method, like I said earlier, I assigned a direction as a positive current direction, like where I assign the current going into every element's positive terminal is positive. Then you will see you still getting the result, all the power adding up to 0. I'm like, okay, what if I assign all the current going into the positive terminal is negative? Well, what you will get? You will get all the opposite result for each element's power. Like for example, P1, we got negative 100 watts. If you assign the current in the opposite direction from the beginning, then you will get P1 equal to positive 100 watts. So you will still end up with the same. You add up all the power together, 0 watts. So I think that I really like when that moment happens. I'm like, oh, that's really wholesome and that really makes sense. So does anyone understand this? Do I make it clear, or you want me to rephrase it or re-explain it in any way? Okay, good. Cool. Okay, here, since you said it's all good, so here is another example. I want you guys to try on solving on first. You will have 5 minutes to calculate out P1, P2, P3, P4. Yes, and starting now. Oh, yeah. Oh, yeah, for the student who just joining, we are doing this example, trying to calculate, you missed the first part, but trying to calculate our P1, P2, P3, P4 is the question of this. And we were working on it together with, after a couple minutes. So if you find it kind of confusing and you don't know how to solve it, don't worry, like we'll work on it together too. yeah, if you already finished working, or you get some answers, feel free to share your answer in the chat. Or if you don't, you can just let me know, okay, I'm done working. So perfect. Okay. Okay, let's work on it together. So first of all, like the answers you guys got in the chat box, I see. Yeah, you are correct. But just make sure everybody still understand how to calculate each element's power. So we're working on this together too. So let's start with P1. Same, I will still assign the current going out from the positive terminal for each element is positive direction. So for P1 here, we have the current going out up here, 9 amp. So P1 is equal to positive 9 amp and times positive 5 volts. So negative 5 volts. What am I talking about? Okay, so I'm assigning corrected. I'm assigning the current going into the positive terminal as positive. So this current here is going out from the positive terminal, which is negative. So we got I here is negative 9 amp for this element. So P1 is equal to negative 9 amp times positive 5 volts. So P1 is equal to negative 45 volts. And for P2, so P2 here, first of all, identify what it is. Here, you don't have to, but like since we just learned this concept, so that's what I like to do and to just kind of practice your understanding. And so here we have a circle sign. So obviously it's independent source, and we have the polarity sign symbols on the sign. So this is an independent voltage source. Okay, and we have the current going into the positive terminal. So making this current positive. And then also going through this direction, the voltage is positive 2. So P2 is equal to positive 9 amp times positive 2 volts. So positive 18 watts. This kind of matching, if you still remember at the beginning of this class, I said, even we have some power source in the circuit, but it's not necessarily supplying the power. So here you can see it's actually receiving the power from the circuits. Okay, carry on. P3. So P3 here we have a diamond shape, so which makes it dependent source. And we have the polarity sign on it, so it's a dependent voltage source. And we have the value of the voltage of 0.6 times I, and I here we see it's 5 amp, so this is 3 volts. So which means we have the positive sign here, negative sign here, with 3 volts voltage across it. So P3, we have the current going into the positive terminal. So the current is positive for this element. And so P3, we have positive 4 amps times positive 3 volts. So we have positive 12 watts. Okay, last one, P4. we have current going down here. So the current is going into this element. And then we have a voltage across this element, positive sign up, negative sign down. So positive voltage 3 volts. So P4 is equal to positive 5 amps times positive 3 volts. It's positive 50 watts. And a quick check, if we add them all up, if we add all the positive up, 18 watts times plus 12 watts plus 15 watts, we got like positive 45 watts. Means this circuit we are consuming 45 watts, and we have negative 45 watts from P1, which is supplying this 45 watts. Plus this together, 0 watts. Makes sense. We have a good answers. Oh, we have a question. Can I explain how the 3 watts? You mean like the P3, why this is 3 watts? That's what you mean? Oh, P3, yes. Okay, so first, we have a diamond. Started with, we'll have a diamond shape here. So that tells us this is a dependent source. And that confirmed with the value here. The value next to it is 0.6i, means the value of this, no matter what the source is, it's the magnitude of the source is 0.6i. And again, we see there's polarity signs on top of this. Positive, negative sign on this shape. It tells us it's a voltage source. So what values we have here is a value of this voltage across this element. So if this is not, if this we see is a diamond with an arrow sign in it, or no matter, maybe it's up, maybe it's down, that tells the direction of it. It's an arrow sign in it that tells us this is a current source. Then the value next to it tells us what's the current going through this element. So here, because we have this polarity sign, so it tells us this 0.6i is the voltage across it. And I here tells us it's 5 amps. So the voltage across this element is 3 amps. Is that clear now? Okay, good. Cool. Does anyone have any other questions, or it's all good? Why does it not the 4 amps? Okay. Good question. Because did you see here it says 0.6i? The I didn't just automatically assign to the current going through this. It assigned to here, this I. You may think about, the question could be, you are thinking, oh, why this current dependent source element is not dependent on the current going through itself, but dependent on a current outside. That may not be your question, but I may explain that too. So the current dependent source or any dependent source, the value is dependent on another element, not necessarily by the current or not necessarily by the voltage across itself. Because if you guys, I don't know whether you guys ever have electric lab or not, there is a device we can, for example, there's other things we can use too, but there's a device in the lab, you can just manually putting into adjust the current. So this whole thing will working as, if you observe, for example, if you want to control this, the voltage going across this branch, so going across this branch, and you want to depend this on another element's response, then you can manually change it according to what you observe observe the current here. So with more complicated system or circuits, after you change this voltage across this, based on the current you observe first from here, this current may change again. Then your voltage across this, you have to change according to that. So it's kind of like an ongoing system. You are adjusting this ongoingly with this current. It giving the response, and then you based on the response change again, and it will adjust again based on this. So it's like an ongoing loop, and until at one moment you reach equilibrium, you reach a stable loop here, then you will get a stable readout. And that's with more, and that's what we're not covering. We're not talking about that process, but we will cover that later in our class. How are you solving with 0.6i? Or how to solve with it? Yeah, that's that. I actually, yeah, you were thinking about like what you are thinking about more complicated. Oh, it may change. So here for I, we are thinking more like it's fixed. The I is what we see here is 5 ohm. So we use this number for here. Yes, like what other classmates answered. It's like we just take the 5 ohm as the I here. Yes and no. So for right now, it is not. We will, as Caleb was stated here, we will just take what we know and we're given on this circumstances. I is equal to a specific value. If the condition changes, if in the future we're facing more complicated system, then we will let you know. We probably will use the small I, like the little I, as like a sign for you, so you know it's like a variable. But for now, it's like a specific value we use here. But I'm glad you are thinking more advanced than that. You are thinking, oh, maybe this will change. Yes, but here it's more like specific values we see. Okay, there will be more examples we can practice on. Here, so here I'm showing kind of like more like application figures. So this figure shows we call it cathode ray tube. This is inside a TV. So it's the TV picture tube where how we see all the colors or the dots light up on the TV screen. This is I think it's kind of a older technology. So at the left end of the tube, you can see we have an electro gun, and the electro gun will fire electron beams out, and the electrons will pass through these two sets of electric fields. And with this external electric fields, the electrons will have certain like distance move from the certain place. So it will deflect because of the field force, and then it will eventually hits on the screen and lights up. Well, here we are not really focused on how this functions and how it works. We will, what we here is here, we will simplify this figure into this example questions. So let's see, this electro beam in TV will carry out 10 to the 15 electrons per second. So let's determine the voltage V0 needed in this circuit to accelerate the electron spin out, so we can have a power. We can achieve the power of 4 watts. So I'll give you 2 minutes to calculate out what the voltage 0 needed here to achieve like power of 4 watts. don't overthink it. It should be pretty easy, straightforward. One hint is like here the value given here, the 10 to the power of 15, this is a charge. That's I make it kind of obvious. This is a charge, the quantity of charge. Okay, you have 2 minutes to calculate. Oh, also, while you guys working on this, I want to see if you don't feel awkward or don't feel hesitate to let me know if even after I so-called I re-explain something and you still confusing or you still don't really get it what I was saying. Don't feel awkward or don't hesitate. Just let me know. If you don't want taking other people's time, you can always feel free to email me or just like I said in my first class, you can just come to my office and we can talk. And if you can schedule a Zoom call with me off class. Just send me an email. I totally understand that. Like sometimes I have something in my mind, but I don't really iterate well enough. And also if you can tell, like English is not my first language. So if it's literally just like I didn't organize my words pretty well and you're still confusing, please reach out, please. Like I won't take it offended or anyway. Like I will try my best. We'll make it eventually works out in some way. So just reach out. Okay, let's look at this together. So as the hint I gave you guys, this number here is a charge. So what charge is? Charge is related, what concept we define with charge? Current. So which also will benefit we here have power and we have voltage, which are all like come together. So we know current, it's really hard to write. Current, this is I, not Z, this is I, okay. Current is equal to dq over dt. So current is the charge change over time. And we have this many electrons, and we know every electrons carry how much charge? Negative 1.6 times 10 to the power of negative 19 coulomb. That's 1 electron charge. And we have this many per 1 second. So we have times 10 to the 15. This is a number over 1 second. Isn't that perfect? Coulomb over second, exactly what we want. And so we got the current is negative 1.6 times 10 to the negative 19, 15, so negative 14 amp. And now we have current. And we have power is 4 watts. And we want to know the voltage. Obviously, voltage is equal to power divided by current. So 4 over negative 1.6. The negative here is actually doesn't really necessarily matter. It just tells us the direction or not. So you can put it down, can doesn't put it down. It doesn't really matter. Here, what we really care is actually like the magnitude of it times 10 to the negative 4. This is watts, this is M. So 4.4, so get up 1. So we got 25,000 watts. Is that correct? Yeah. Yeah, I think that's 25,000 watts. Right, yes. Questions? I guess it's good. Okay. Here, let's do some quick review on this one. So I want you guys to, oh, you get DTS. How did I get DTS? 15. What do you mean by 15? I don't have 15. You mean, okay, I will redo the current one. I think you have problem with you have question on the current. So we know current is charge change over time, right? Over time. And here we said, since the tube carries 10 to the 15, 10 to the 15 electrons per second, which means we have, this is the number of electrons we have per second. So we have we have like a dn, which is a quantity of electrons over dt is equal to 10 to the power of 15. So here dq, the charge is actually little q, which is a charge of electron times number. So if we replace the q with q, little q with n, we'll get d little q times the number dt. And since the little q is literally the charge of electron, which is a constant, we can take it out. So we have, this is, yeah. So we have a little q times dn over dt. Like I said earlier, the dn over dt is given as 10 to the power of 15. And we know the q is a constant. We can look it up. It's negative 1.6 times 10 to the power of negative 19. So then that's how we get the current. Okay, another questions. How do we get rid of the negative? Oh, we didn't. Oh, so yeah, no. So yeah, you can see it's negative 25,000 volts. We didn't. So for the negative, positive, negative, for the current, for the voltage, it's all just giving us, more likely to giving us a concept of the direction. So it doesn't, what we care about is whether the magnitude is correct. If we get a negative signs of it, it means it go against. So it go against what we assign at the beginning, or we always will assign a direction of a positive direction. So if we got the answer of the value of it is negative, which means this direction we assigned earlier was like wrong. We should like turn it over, like it should be the positive, like the polarity should be like the opposite. So you will see more. So here we didn't really assign any direction. It just kind of carry out with this, like the question itself. Later on with more practice, you will see when we assign a positive direction to the circuit, sometimes it's not always correct. We'll assign in an opposite direction, which is the result coming out with, and you will see, you will reflect as, we will get the value, the voltage or the current value as negative. Then you will know the direction you assigned earlier should be the opposite direction. Yeah. Okay. Ethan, I think you understand yes and no. I won't normally we'll see if you see the power, sometimes you calculate out the power is negative. Because power normally, if you given condition, the power is normally given as a positive number, but sometimes you calculate out as a negative. We see it's because it's giving out, because we are looking at this more like the system against this one element, and it's giving out the energy, and that's providing the power to the system, then that's seeing a negative. But if we are seeing the voltage is negative, or the current is negative, it's most of the time it could be when we assign a positive direction to this circuit, and the actual current or positive is not following the direction we assign, it's go against it, so that giving the negative. Well, it's kind of confusing for this example, I'm sorry. But later with more example, you probably will get a better understanding. If you still don't later on, then we'll review this. Let's carry on.
No, it's okay. I think I just got confused. It's okay.
Oh, okay.
I think I'm all good now. I'm all good now. Thank you.
Okay. Yeah. If there's still other, like when some other example comes up, and we can discuss more.
All right, perfect. Thank you.
Mm-hmm. Oh, we are running a little bit. Well, I have way more examples. Okay. Here really quick, like this is just example. I want to review a little bit with you guys. To identify the power source in this figures. So obviously we have this too. So anyone can just like answer this really quick. What do you think this power source is? Like what type of this power source is? Anyone have some answers?
The independent voltage.
Yes, correct. It's independent voltage. And what about this one? Be careful, be careful. It can be tricky.
Dependent current.
Yes. I'm glad you didn't trick by like the value here, because I actually changed it. Like this is the example I took from the book, but the book have like dependent to the current. But I'm like, I'm gonna trick it. So I changed it to the VS. So I was thinking maybe some people will like thinking it's a voltage source. No, always pay attention here. This is the arrow, so it's a current source. And no matter even it's like the value of it is dependent on the VS, but it's still good. You guys know that. Okay, I'm gonna skip this one. It's pretty easy, and you can revisit because we are kind of running out of time. And you can revisit. I'll post the slides online if you want. You can just kind of look at the slides and just do the practice yourself. Yeah, there's way more. I want to do this with you guys really quick. So first of all, it looks kind of more complicated circuits. First of all, I want to ask you guys, what V0 you think here is? What's the voltage across this element? don't get fooled by like all this, like looks kind of a lot of like other elements, just trying to focus. What's the voltage across this one? I got 18 volts. Anyone else? Anyone? Yes, correct. It is 18 watts. Yeah. It should be really straightforward. Yeah, don't get fooled by like all this. They are all connect to this two nuts. So they are all parallel to this one element. And then across this two, you can see here only supply with 30 volts. And here we have 12 and here we have 18. So, okay, we're really running out of the time, and I will post the slides on Canvas so you can revisit all class and just practice. And they are just similar example as we did earlier. And the key to success this class is literally practice. Learn the concept and use the method practice. And all the tests and exam we will have is all similar to the examples we have in class or the homeworks. So yeah, any other questions?
I have a quick question. Are
Okay.
these are the answers to the examples, are those posted on Canvas somewhere as well? Like to
Oh
check
yeah,
our work after we do it?
I will have all the like answers on the slides when I post the slides.
All right, thank you.
I post the lecture record? Yes, I do. Yeah. Okay. Yeah, I do post the lecture recording. I already posted the first yesterday's class recording online. If you guys cannot see it, just let me know. I'll also post this one. So I always post the slides and the recording. If you guys want to review the recording or you miss the class, you can always just watch afterwards. Yeah, if you guys don't have any more questions, then feel free to leave the class. Thank you, guys.
Thank you.
Yes, the homework hasn't assigned yet. I will assign Friday, and I will also send out emails to let you know. Yeah, see you Thursday.